What's up, guys? Today we're going to take a look at the implicit derivatives. Implicit derivatives, you use it when you have two variables being multiplied together in the function, or the other variable has a power. So if you're in this case taking the derivative with respect to the x, we have x and y being together and then y squared. So we cannot use the regular or normal, the easy derivative rules. We have to use the implicit derivative. Okay, so in this question, if you look at it, we have actually three parts. So it says find the points at which this ellipse crosses the x-axis. So that's the first one, right? This is the first one. And hopefully you recognize it as soon as you see crosses the x-axis. This is the x-intercept. So you're looking for the x-intercept as the first part. Now the second part is then to show the tangent lines at these points are parallel. Well, in order for you to see whether two lines are parallel, you have to know their slopes, right? If the slopes are the same, they are parallel. Well, obviously with a different y-intercept. So the second part of the question here is to find what the y prime or dy over dx is, the slope of the tangent line. And then the third part is to compare them and see whether they're the same. So let's take a look at the first part. The x-intercept is always written as a x comma 0. So in order for you to find it, simply we just plug 0 into the y's. Then we get x squared equals 3. Therefore, x equals plus minus square root of 3 by taking the square root of it. Be really, really careful with the plus minus sign, okay? When you are taking the derivative of an equation, there's got to be a plus minus sign in front of the square root, okay? Don't forget that. So we have the x-intercept of square root of 3 comma 0 and then negative square root of 3 comma 0. So we have 2 points. Now then the second part, let's go into the second part. As I said, we are going to be applying implicit derivatives instead of a regular derivative rules. That's again because of x and y, two variables being multiplied together, non-x variable being powered. Well, it could be the other way around in terms of the x or y, but in this case we're taking the derivative with respect to the x. That's why I said y being squared. Well, that's one of the reasons why we have to use the implicit derivatives. So instead of using just y prime, what I'm going to use is dx over dy or dy over dx. Okay, so I'm going to use dx over dx or dy over dx. So the first one, we have x squared, so it will be 2x and then dx over dx. Now minus, we have to start with the brackets because we have the product rule, meaning we are going to have two terms. Therefore, the negative sign in the front, this one, has to be distributed to the both. So in order for us to, in order for us not to get confused, let's put the brackets in the front. So we then have the derivative of dx. So that becomes dx over dx y, and then plus x dy over dx, and then close the brackets, plus 2y dy over dx equals 0. Well, constant, if we take the derivative of that, that's always a 0. Now, dx over dx, they basically goes away. We can now do that. Then I'm going to switch the dy over dx into the y prime so that it's easier for us to just write it. So we have 2x minus y minus x y prime plus 2y prime, sorry, there's got to be y, so 2y y prime equals 0. So we're trying to find what the y prime is, so obviously we're going to move this to the other side to isolate the y prime. So we have negative xy prime plus 2y y prime equals negative 2x plus y. Now, once you have that, well, if you take a look at the left side, which has the y primes, we have two terms, but with both y primes. So we factor the y prime like this, so that it becomes this times that, so that we can divide everything by negative x plus 2y. Now, if you do that by negative x plus 2y, then we will be able to finish that up. So y prime times negative x plus 2y equals negative 2x plus 2y divided by negative x plus 2y. Then we get y prime equals negative 2x plus y over negative x plus 2y. So the second part is done, right? Second part is done. Then last part is to see whether they are parallel, so we have to find the slope. Well, remember this, y prime represents the slope of the tangent line at a point. So in this case, at the two x-intercepts, so we all have to do is just to find y prime where x equals square root of 3, and then try to find y prime where x equals negative square root of 3. And all we have to do is just plug the numbers into what we have and compare them, okay? So we have negative 2 square root of 3 plus 0 over negative square root of 3 plus 0. Now you probably ask me, where did I get the 0 from? Well, when the x is positive square root of 3, your y value is 0, right? That's where I got the 0 from. Now, if you then simplify this, this becomes 2. Now, let's then take a look at the negative one. So we have negative square root of 3 as the x. That gives me positive 2 square root of 3 plus 0 over positive square root of 3 plus 0. Again, the same reason why the y is 0. Therefore, I have y prime at x equals negative 3, negative square root of 3 being 2. Therefore, they're the same, so they are parallel, okay? So that's how we can do these type of questions. So again, remember this. This is kind of popular question to be on the test, and that's because it has so many parts already embedded in without explicitly saying part A, part B, part C. So your job is to distinguish them and then to figure out which rule or which way of taking the derivatives you use, okay? So hopefully this helps you guys prepare for the test. I'll talk to you guys later. Bye.